Okay, I am back on the right operating system so that I can now run Visual Studio. So I'm going to run Visual Studio, and I just want you to see just a few things that I do that might help you at home as you're working. So if you're starting a whole new project, what you would do, like right now, I already have add to some here, and I have another project over here. I could open that, but I'm not going to do that. I'm going to go ahead and create a new project, and which is what you would do at home, an empty project. Next, and I would give my project a name. So let's call it lecture example. And then the location that you choose is whatever you would like to use to keep your programs. So I went ahead and created a assembly language class folder on my desktop. That way it's just easy for me to find things. And then we're going to press create. Okay, so when this comes up, you're going to right click on the name of the project that you just created. And the first thing you want to do is just make sure that MASM is checked off. If you have that checked off, then you are good to go from here on. So we press OK, and there's really nothing else that you have to change. The next step is, well, there is actually, I lied. So up here where it says 64, we change it to an 86 processor. And so we have MASM, we have 86, and then we want to right click again on the name of the file, and this time we're going to create our program. So to do that, we're going to click add. Now you have two options. You can add a new item, or you can add an existing item. If you add a new item, then it's just going to be a blank page where you get to enter your code. I went ahead and gave you this code. So if you put the file that I gave you that you find with, so it looks like, I'll show you for a second. The file that I gave you is called add to, it's right here, add to with the extension ASM. So if you just put that on your desktop somewhere or put it in some folder, then you can just add it. So we right click, add an existing item, and then I'm going to grab the one on my desktop. Add to .asm. And if you try to create a new one and you try to copy and paste, like let's say you try to copy and paste from the PowerPoint, it's going to give you an error because it copies some special codes that are on the PowerPoint, and then it tells you that you have, I can't remember the error, but some character that it doesn't understand, and there's no way to get rid of it. You just have to start new. So don't try to copy and paste that. You can, there's certain parts in your book that you can copy and paste from. Anything in your book that doesn't have like the line numbers, it's typically a good, something that you can copy from that won't have any special characters. Okay, so if we open this program, then this is the same program that's in your book. But notice that at the top, I've added the comments. So I've added author, date, and description. This is a convention that you're going to follow for all the programs that you submit for the class. So here, we're taking the value, we're taking this literal constant phi, and we are moving it into, putting it into this register, EAX register. And then we're taking the 6, and we're adding to EAX, and we should get 11. Now, when I run this program, I'm going to go up here to local Windows debugger, and I'm going to run the program. And then it says this project is out of date. Would you like to build it? Yes. Now I'm going to get this window here. This is my console window, and it should say that everything down here, it should end with exited with code 0. So exited with code 0, remember, it means that everything went fine. We're at the end of main, and we can exit without a problem. This doesn't display anything on the console. It just puts some things into the register. So what I want to do next is I'm going to go ahead and press enter and go back here. I want to step through the code, and I want to see what's in my registers. So this is something that you can do to debug your program. And if you've used Visual Studio before, you know how to do this. So here I'm going to click on where I want the program to stop. And then it stops at this line, and then I'm going to step through. So when I step through this line, then it executes this line. So it's going to stop before it executes this line right here. So I didn't get to this earlier, but main is just like when we do main in C++ or Java. This is where we're going to begin our program. And this is called the main procedure, PROC's procedure. This is the end of the procedure. So we call it main, but it doesn't have to be called main. But we're going to call it main because that's what we call all procedures that, like in high level languages, you know, like Java and C++, C, we have main. So we're going to call it main. We do have to have PROC to say this is a procedure. This is the end of the procedure. And this is end main. And between here and this end right here, you can have more code. You can have other procedures. Like in C++, you have main, and then you have functions at the bottom. We can do that here. We can have other procedures that we call within the main procedure or within other procedures. Everything after code is going to be, of course, our program. Here's where we're going to declare our variables, and we don't have any variables to declare yet, but we would declare them in this section, in the data section. We have the data section and the code section. And again, these are directives, and it's just to make it clear what section where we're at. We could call this start, you know, whatever we want to call it. So I've got the breakpoint here. And then what I'm going to do is I'm going to right click on, so first I'm going to run the program. And down here, I see my registers. So right now, all I'm going to pay attention to is the EAX register. Notice that the EAX register has some value. This is a hexadecimal number. And I haven't stepped through EAX yet. So I don't have the 5 in there yet. I just have whatever was in memory. Remember that memory is may not be clear. It may be garbage in memory. So that is what's in memory right now. So I'm going to step through by, there's different ways you can do this. So debug, step into F11. Because I am running on, so I'm on a Mac that runs 2 different operating systems using Boot Camp. I'm just going to use debug step into instead of F11, but you can use F11. So when I step in, 5 then gets put into EAX. So there's the 5. And this is a hexadecimal number, but 5 is just 5 in hexadecimal. And then I'm going to go debug and step into again. And then now 6 got added to the 5. So my register has 11. Remember that A, after you go 0, 1, 2, 3, 4, 5, 7, 8, 9, A is 10, B is 11, C is 12. A, B, C, yeah. So we go C, D, E, and we stop at E, which is 15. So A, B, C, D, E. We start at 0, 0 through 9, and then A through E. Sorry, I forgot F, A through F. So we have A, B, C, D, E, F, the 10, 11, 12, 13, 14, 15. F is at 15. All right. So now I've stepped through it and I see that B is in my register, so everything worked well. So if you want to see what's in the memory locations, what's in your registers, what's in your variables, you can do that by using the debugger. By the way, if you don't see your registers down here, then while you're running, what you want to do, so run the program first, step, put the little dot, run it, and then click on the name of the project and go to properties, go to Microsoft Macro Assembler. No, that's not where we want to do it. Let me think here. This is for the listing file. I want to see the registers. So right click properties. Oh, no. Debug windows. Here we go. Go debug windows and then registers down here. Debug windows. But it has to be running, okay? So have it running and then go to registers. And then once you click on registers, then it should show you the registers down here. So I'm going to go ahead and run it again and step through it again. Oh, okay. Okay, so like that. Oh, it's telling me to continue. So let me finish the program first. Continue. And then step through, debug, step into, and debug, and step into. Okay. So once again, we have, and then continue, and it's going to stop. So once again, we have our main procedure. This is the end of the procedure. We have to have this line here, and whatever we call this here. So if we call it exit, then we're going to call this, then we call it exit P for procedure. So hold on, let me take out this breakpoint. I don't want the breakpoint. So then we run it. There were build errors. Would you like to continue? And then the last, okay, no, I want to continue. Okay, so did not like that for some reason. So let's make it back to process. Okay, so maybe we can't change it. All right, so we're not going to change it because apparently it's not liking exit process to be changed. Okay, so I'm going to go ahead and pause this for a second and then go back to our presentation. So in the previous, in this slide, we just had, I just want you to go ahead and test setting a breakpoint, running the program, debugging, stepping into the code, and then make sure that you can see the registers, and then look at your registers, remembering that's a hexadecimal number, and this is how you're going to read the values. I think, okay, so suggested coding standards. So these are standards that are suggested that we use. Either capitalize all the reserved words, including instructions, mnemonics, and register names, like capitalize EAX, capitalize MOV, like stack, etc. Or we could just capitalize the reserved words. So we're going to follow, we're just going to do what the book does and capitalize whatever the book decides to capitalize. And you'll see, if you look at other videos, you'll see the programmer capitalizes all of the mnemonics. But we're going to keep it consistent and just do how the book capitalizes. And remember, this is not case sensitive, so it really doesn't matter. Other suggestions, we already talked about descriptive identifier names. So the names of the procedures and the variables and the constants, all those, they need to be something that is descriptive. Let's put spaces around arithmetic operations. So if we're going to say like 5 times 3, go ahead and put spaces around that. We're going to use blank lines between procedures. So we're not going to scrunch everything up. We're going to indent and have some spacing. So when there's a code or a data label, we're not going to have an indentation. But when we have an executable instruction like MOV and move and add that we just had, then we're going to go ahead and indent those. So we'll have main procedure, all the code indented, and then end our main procedure. And that's the same thing that we do in other languages. Comments are on the right side of the page and they're aligned vertically. We're also going to have the comments at the top for our header information. And we're going to have a few spaces between the instruction and its operands. So maybe put 2 spaces here. And then you can just put commas in between these. You don't need spaces. Again, these are conventions. A lot of these, of course, a space is required between MOV and the register, at least 1 space, but we want to put a couple of spaces just to make it really stand out. So there's certain things that are required, certain things that are not. Spacing and the blank lines and the capitalization. A lot of that just has to do with readability. So we want a programmer that comes behind you to maintain your code to be able to read your program. I'm really big on readability. When I worked in corporate, we had code reviews. Our code got reviewed by a group of people, so they would look to see, did we have the spacing? I mean, that's important. Did you make your identifiers the way that the company wanted you to name things, following the conventions, like did it start with a lowercase and second word with a capital letter, things like that. And then we're going to have 1 to 2 blank lines between the procedures. Okay, the next section is assembling, linking, and running a program. So what happens when we do this? So we're going to talk about the assemble, link, execution cycle, the listing file, and the map file. So the following diagram describes the steps from creating a source program through executing the compiled program. So we start here with the source file. So this is what we just created. We created our source file in a text editor. We used Visual Studio. And our text editor is a what's the name? Anyway, we're using Visual Studio. Sorry about that. And then, so our text editor takes our source file and it assembles it into an object file. The object file has the machine language. So this is going to be machine code here that the machine understands. It can also, at that point, create a listing file if we ask it to create a listing file, which we'll talk about next. An object file, if the object file has procedures that are in libraries, then the linker is going to take those procedures and it's going to put them together with the object file. Then the linker will take whatever link to libraries and object file that's all together, and it's going to then translate it into the executable file. And then from there, it goes to our operating system to be loaded. So the operating system loads the executable file. So the linker is the one that's creating the executable file, not the assembler. The linker is the one that's making the executable file. The linker is also putting together the procedures that were used from libraries into the object file. It doesn't put it in the executable file. So the listing file has these things in it: source code, addresses, object code, which is machine language, segment names, and symbols. Here's what a listing file looks like. And you'll be able to actually create your listing file. So it's going to have the code, and then on the left-hand side, it's going to have these items: addresses, object codes, segment names, and symbols. Okay, so the next thing I want to show you is how to create a listing file. And so when you're in Visual Studio, you're going to, I was trying to do this earlier, you're going to click on Lecture, Example, Properties, Microsoft Macro Assembler, and then listing file. Then you want to make sure that this is set to yes, and this is set to yes. And press OK. So again, we're going to right-click, Properties, Microsoft Macro Assembler, listing file, and then make these two properties right here yes. So now when we run the program, it actually creates the file. And the file is going to be created in the same folder that you have your add to ASM. The listing file will be there, and it's going to be a .lst extension. And we're going to talk more about the listing file, but I'm going to go ahead and end this video right now before my battery and my computer stop. And we'll continue with listing files and the rest of the presentation next time. Okay, so play around with Visual Studio and make sure you can run your first program. Thank you.